I think I can't share when you're still sharing yours. You need to first stop sharing your screen. Yes. Can you see the screen now?
Yes, very good. Remember to put it in the slide show mode.
Is it in the slide show mode now?
Yes, very good. Thank you.
Okay, thank you.
You can stop sharing.
All right.
Thank you, Madam Jacqueline, for joining. Can we test, please, also your camera and your microphone?
It's fine.
Okay, very good. Thank you. Thank you very much. Okay, thank you very much. Thank you for joining the 6th Nile Basin Development Forum. And we are starting a new theme about climate change for adaptation. And today is the first session, and it's about climate change impacts on the hydrology of the Nile Basin. The Nile Basin Initiative, in collaboration with the government of Ethiopia, is organizing a series of webinars in the 6th Nile Basin Development Forum. And under the theme, Rethinking Regional Investment in the Nile Basin, the Science Policy Practice Dialogue is organized to bring together MBI with the stakeholders for the Nile Basin countries, from the Nile Basin countries, and also around the world. The goal of this 6th Nile Basin Development Forum is to enhance transformation processes in projects that will contribute to Nile Basin Initiative shared vision, which is to share sustainable socioeconomic development through equitable utilization and benefit from the common Nile Basin water resources. We have different themes under this Nile Basin Development Forum. Themes related to water resources management, environment and wetlands, water, energy, food nexus, adaptation to climate change, transboundary water governance. We already finished all the sessions related to the wetlands and also related to water quality and groundwater. And today we are starting this new session about climate change impacts on the hydrology of the Nile Basin. Allow me first, please, to thank the different panelists for coming on time. I would like to thank first Madam Jacqueline, the TAC of Rwanda, and the Nile TAC Chair, the current Nile TAC Chair. Thank you for coming. I would like to thank also Wilberforce. I would like to thank our rapporteur, Ammar Jaber. I would like to thank also Anna Kaskau from the GIZ. I would like to thank Emmanuel, Dr. Maha. I would like to thank Leonard Akwani, Nicholas Aza, and finally, Sintayo. Thank you all for coming on time. And we are going to start with some opening remarks and an inspiration by our Nile TAC Chair, Madam Jacqueline. Madam Jacqueline, the floor is yours. Thank you.
Thank you, Doctor, for welcoming us in this session regarding climate change impact in the Nile Basin hydrology. So allow me to say a few words during this webinar, just for opening this session. Do you hear me?
Yes, we can hear you very well. Thank you.
Thank you so much. Dear colleagues, NITAC members who are may be in this session. Executive Director of Nile Basin Initiative, development partners who are present here, management and staff of NBI, ENTRO, and NELSAP, dear panelists for today, ladies and gentlemen. It is my pleasure to welcome you to this webinar under the theme Climate Change Impact on the Hydrology of the Nile Basin session. I would like first to take this opportunity to thank the Nile Secretariat Management Team for the effort made in organizing these webinar sessions, despite challenges brought by COVID-19 that the world continues to face. Dear colleague NITAC members, ladies and gentlemen, the Nile Basin is one of the most critical transboundary water basins in Africa, with the river Nile playing a crucial role and resource for most of the economic and social activities for the countries in East and Northern Eastern Africa. That said, it is equally facing adverse effects of climate change, which is expected to worsen in the future should little or no efforts be done to avert the current trends. Dear TAC members, ladies and gentlemen, we all know that water, food, energy nexus approach is a fundamental concept during this period where Africa is facing climate change threats. Some of the associated challenges of the river basin include drought and flooding, heavy siltation, deteriorating water quantity, quality, and distribution, and so on. To address all these challenges, it requires an integrated planning of water resources and close collaboration, not only within the basin, but also among river basin organizations. This is within the backdrop that the region has high population growth, strong emerging economy, and huge demand for its environmental services, all which place an unprecedented demand on the water and environment resources within the basin. Dear colleague TAC members, ladies and gentlemen, the climate is changing, putting a range of natural and human systems at risk and prompting communities, governments, and organizations to step up their efforts to adapt. The food and energy security, as well as enhancing countries' resilience to climate change, form the key goals in recently adopted in NBI Kenya's strategy. The learning cover can be steep, but certainly manageable given the wealth of methods and information to support adaptation planning. The goal is to manage current and future negative outcomes and capitalize on opportunities that may present themselves under a changing climate. Dear colleague TAC members, ladies and gentlemen, let me extend my gratitude to NBI development partners and our stakeholders for their valuable contribution to the sustainable development of our region. With these remarks, I declare this session officially open and wish you fruitful deliberation. Thank you for your kind attention.
Thank you very much, Madam Jacqueline. Thank you for these inspiring statements. Thank you very much. Madam Jacqueline is the Nile TAC Chair of the Nile Basin Initiative. Thank you very much for these inspiring statements. And now we are going to share with you first the keynote presentation. Okay. In this presentation, I'm going to present to you the Nile Basin Initiative experience on climate change. So I'm going to share with you our experience here at the Nile Basin. Okay, so first of all, this is like one of our important studies about preparation for climate change data set related to global circulation models and also related to regional climate models. This is one of the important studies, and we made like bias correction to this climate change data set, and they are available for all our stakeholders over the Nile Basin. And we here at this project, we even classified these models based on different things, based on capturing the streams, based also in their annual variation, on their seasonal variation, on their skills and independence. Here also we checked which models capture well the drought, which models capture well the flood and wet conditions, and also as I indicated, and here you can see the models also for each sub-basin. We have 10 large sub-basin here over the Nile Basin, starting from Lake Victoria, Victoria Nile, Lake Albert, Bahr al-Ghazal, going up to Blue Nile, White Nile, and the main Nile. So here we ranked these models. We made bias correction also for these regional climate models for different scenarios. Representative concentration pathway of 8.5 and representative concentration pathway for 4.5. What we did also here at MBI, we tried to look at each sub-basin, what is projected at each sub-basin. What are these models telling us? Are these models projecting more rainfall or normal condition or dry condition? So here you can see on the right for some few sub-basins, what are these models telling us here? We also used our Nile Basin Decision Support System tool. We used as an input this projected data set, and we generated the flows over different stations for different scenarios, the RCP 4.5 and the RCP 8.5. And here you can see these are some stations over the White Nile. We also did the same for the Blue Nile. This is also one of our products. It's about Nile Basin River Flow Forecasting System. This is during the preparatory phase. And here, this is our model. Now, it is online and anyone can access that model, and he can check different kind of information related to water levels in the reservoirs, also the flows, and other kind of information related to rainfall and other parameters also. This is also another product which we developed here also at the MBI. It is about drought monitoring and forecasting, and you can get a lot of information and indices. We generate a bi-weekly report, and we share it monthly with our stakeholders. But on the same time, anyone can access our website, and he can present and he can generate different kind of information from that website. These are also different products which we made here. We generated 10 products related to the impact of 1.5 and 2 degree increase. What does it mean for the Nile Basin? So for each Nile Basin country, we generated a report. This is also one of our products here. It's a quarterly bulletin. We generate different kind of information related to the rainfall, to the evapotranspiration, and also to the water levels. And you can see in this graph, this is the average, and this is the water level, up to near real time. This is also one of our projects. It is climate services for infrastructure. It is also one of the important products. And here, for the first time, we introduced a new term, which is climate risk assessment. So same like environmental impact assessment for any large infrastructure. Here, we introduced also this new thing, which is climate risk assessment. And under this project, we are doing also different activities by the support of the GIZ. So NBI is progressing well in terms of data preparation for impact studies, and it enables also NBI to foster cooperation in the Nile Basin. And thank you very much for listening. Thank you. Okay, I would like, before I start with our panelists, I would like just to remind you with some few housekeeping information. Can you kindly please maybe type your name, affiliation, and country of residence in the chat room box so that other participants can know who's present. And also for speakers, please mute your mic and turn off your camera, except when you're speaking. And please also use chat room to share and exchange ideas. Also, please use post questions in Q&A feature. This will be responded to by the resources person. And now we can start with our panelists. We can start first with Emmanuel. His presentation is about the impact of climate variability and land use change in stream flows in the upper Ruizi subcatchment in Uganda. Thank you very much. The floor is yours, Emmanuel.
Yes, thank you very much, our moderator. Emmanuel Aranayitwe from Uganda, and as they said, I'm presenting. I want to first share the screen. Okay, you can see my screen. Hello.
Yes, thank you very much. Yes, we can see it. Thank you.
Yeah, Emmanuel Aranayitwe is my name. I'm from Uganda, related to the Ministry of Water and Environment, and I'm presenting on the impacts of climate change, climate variability, and land use and land cover changes on the stream flow of the upper River Ruizi. As we are all aware, and we all know that water resources globally are under pressure, of which this pressure is coming from changes in our climate and human activities which are taking place, but also the rapid increase in population and economic development. Climate variability is the major contributor, or the main contributor, to the stream flow. This is in addition of other human activities, which may include direct abstraction of water for different uses. However, in the recent past, we have experienced a number of deforestation a number of challenges or factors that contribute to land use changes, which include deforestation, expansion of agricultural land, and use of urban and rapid growth of urban centers. In our catchment, in our small catchments, which contribute in our bigger Nile Basin or in our bigger Nile River. And these factors, especially human-induced factors, have a great impact on the stream flow. One may ask why I looked at a smaller catchment. Of course, the Nile River is a big one, but there are so many small catchments which contribute to the flow, and of course the Lake Victoria. You may agree that our management strategies, practices, and actions that we are undertaking may not be good enough to address the challenges of human activities and changes in our climate. And therefore, one would really want to know what could these two factors, how could these two factors impact on our water resources? And under this theme or under this webinar that is majorly looking at the impacts of climate change on the hydrology of the Nile, would then answer some of these questions. As a small catchment called riveries exist within the Victoria Nile, and I just picked an upper catchment, an upper part of this catchment, as you could see on this map, to try and see how does climate variability and human activities affect the stream flow of this small river. It is gauged somewhere in Mbarara at New Waterworks here in Uganda, and this river traverses a number of parts within the country and where urbanization is taking place until it finally drains into Lake Victoria. It's about 8,554 kilometers, but this small study focused on the upper part of this, as you could see, which is about 2,028 kilometers. This is how it is gauged, and this is how it flows. There are a number of environmental challenges within this catchment. A lot of charcoal burning, a lot of timber harvesting is taking place, and this has really affected the catchment, looking at the high rates of urbanization and developments, human developments taking place. In the recent report of the State of Environment report, we lose about 112 kilometers of forest in this bigger catchment. So you would really see that such loss or such impact due to human activities could be big, and could really call for a study to understand how does this affect our water resources, especially the surface runoff and stream flow. I focused just to assess the key variables of climate, precipitation and temperature, then evapotranspiration, how this has changed in over 30 years. And then also look at the changes or the trends within land use and land cover, and how then the two would finally affect the stream flow of this small river. This was just a simple study. And because of the variations in temperature and rainfall that have been observed in this catchment, Then I had to first understand what are the trends in there. And then how does the loss of our vegetation, or how do the changes within the land use affect surface runoff? We used simple statistical methods of climate data analysis, the Mancandle and our confirmatory test for sand slope and the T values. But when the data from 1988 to 2014, when it was analyzed, we realized that the trends in temperature and rainfall is increasing, but even when it is increasing, it's not significant. But the evapotranspiration part showed us that there is some decrease. There is a decreasing trend, but which is also not significant, which could probably be as a result of the deforestation and maybe relative humidity and wind. But the other two key, which was precipitation and temperature, were increasing. And then we used the existing land maps or land use images that were available and very clear. And this we realized we could only get within a limited time of about 15 years, which was from 2000 to 2015. And we analyzed the different trends within the selected land use classes or types. These were 6. And as you could see that natural vegetation is being lost at a very high rate. And agricultural land, built up land as a result of urbanization is increasing. This is what we intended to focus on and see how this affects the surface runoff and maybe subsequently what is happening now in terms of the floods. You could only now check the impacts of the two through a model and then set scenarios and see what could, because as water resources managers or water resources practitioners who are in this sector, one would want to know what causes bigger impact, what is behind the impact of this stream flow. And so we set up, we could see these are the land use images where the urbanization is taking place much within the southern part of the catchment. So we had to build up scenarios, which were 4, and run one with changes in land use, keeping our climate constant, and then changing the climate, but keep our land use constant. So we picked a model, and here we used SWOT because it would quickly pick the physical conditions of this catchment, which really varies in terms of the other physical features, mountains, and then some wetlands, especially in the lower part, to try and analyze where the impact is coming from, what influences the stream flow. So the model was calibrated to show with a certain period so that we can be able to take the analysis. So we used the period of about 4 years, 4 years from 2000 to 2014, where we had good images, and then later from 2010 to 2015. So that we can now alter and see what would be the impact on different water balance components. As you could see, in our first scenario where we had the land use changing, we had very impact on our water balance components. Yes, now you may look at them, and when land use has changed, the impact is slightly smaller, especially on runoff, lateral flow, ground flow, and the water yield. But when climate has changed, then you would realize that the impact on these water balance components is slightly a bit higher. And so you could get the baseline scenario and we subtract it from the subsequent scenario that we would analyze in terms, maybe that would be climate or land use. And so we realized that in this, the scenario for climate was scenario 3. We realized that here, we realized that here climate had a bigger impact on these water balance components compared to land use when you could look at the baseline scenario, which was from 2000 to 2014. You could look at groundwater and see how it would increase when climate has changed, or when we have taken 15 years, and we assume that there could be variabilities within climate and our seasons. So the stream flow would increase, and then when the effect is combined, it would have a bigger impact. So that means that our climate, which has been quoted for rainfall to increase within the tropics, is likely to have a high impact on our stream flows. And if the urbanization, if the land use changes and built up and all these land activities taking place on the land, then we are going to have more flows, and which would result into bigger floods, because our land that would have slightly reduced on these flows has been turned into a hard surface, I may say, and this is what we are now experiencing. So in general, as I said, that climate variability has a bigger influence, and this has been also reported in the ICP report of 2007. So we need to be mindful of how do we then plan properly regarding to our land use, to be able to counterface the changes within our climate or the variabilities within our climate within the entire basin, and then take some measures of what now would happen if we are going to have more shorter rainy seasons and slightly bigger dry seasons. Then we have to do some kind of water harvesting in order to increase or to provide water for different uses, but also to reduce pressure on the stream flow, so that we can have more water for flowing for other uses. But also the application of models within the Nile, even from other studies, it needs to be backed up by data. And I think rehabilitating our stations within this basin is going to be a very good achievement, a very key activity, very key thing that we need to take into consideration for us to improve our models. The previous presenter was presenting on the work NBI is doing in regards to climate and the data and how it is used for decision making. Really, I think you would have encountered this, that without good data in our key stations, especially along the Nile, then it would affect our models and the performance, and therefore subsequent plans or actions that we take. I thank you so much. That's the end. Hello.
Thank you very much for the excellent presentation, Emmanuel. Please stay with us. At the end, you are going to have to respond to some questions. Thank you very much. I will just would like to remind our participant of some few housekeeping, please. You can type your name, affiliation, and country of residence in the chat room, so that other participants can know who is present. And please, for speakers, mute your mic and turn off your camera except when you are speaking. And also, please use the chat room to share and exchange ideas. The chat room, the button is below. Please, you can share and exchange ideas. You are also welcome to post questions in the Q&A feature. This will be responded by the resource person later. Thank you. So now we can go to our next presenter, our next panelist. The next is Santiago. He is going to present to us the hydrological response to climate change of the Blue Nile River Basin. Thank you. Please welcome. The floor is yours.
All right, okay. Okay, hello everyone. Good afternoon. Thank you for having me. My name is Santiago Gabri from Leuven, Belgium. Normally, actually, I'm an assistant professor in water resource engineering and hydrology at Jimma University, and a PhD researcher fellow at Leuven University here in Belgium. So I'm going to present one of my research over the Nile, that is the hydrological response to climate change of the Blue Nile River Basin. So the intention of this research is that to see the climate variability projections under different GCA model outputs, and also to see the simulation of the runoff over the catchment. So normally climate change, that is, it's referred to the change in climate variables. And according to the IPCC report, that in the future, the climate change variable will change, especially for the rise of temperature in average in between 1.4 up to 5.8 degrees centigrade by the end of the century. So normally climate change has significant impact on different aspects on agriculture and energy demand, and also in water resource availability. That normally disturbs the hydrological cycle, then it creates abnormal situation on the water cycle on a given region. Especially the impact will be significant at high resolution level at regional and a local scale. So according to IPCC findings, is that in the future developing country will be prone to climate change, and Ethiopia is in developing country, so that there is expectation that more climate impact will be occur in Ethiopia. So there is a need to see and study and assess all the impacts of future climate change on different aspects in agriculture, and especially on water resource availability. So normally we see that climate change are two phases. The two extremes. That one is the drought extreme. That is, it results to reduce crop production at farmland level, and also it will be an issue for conflict and the loss of livestock for animals, and also there will be a shrinkage of wetlands and drying of the grasslands. This is typically taken from North Ethiopian part, where you can see that there is a shortage of grassland for animal grazing, and also a shortage of water flows on the river. And the other phase is that normally climate also have the other extreme impacts, that you can see that flood impacts. And here, that agricultural farmland is flooded with high flood, and it causes human displacement and the loss of animals in human life. And this picture has been taken in September 2020, where there is high flood in the Stady area in the peripheral of the Lake Tana. So the objective of this research is that to evaluate the hydrological response to climate change are two scenarios of horizons, that's 2030 and 2070, using RCP scenarios of 5 GCA model outputs. So we try to see that the projection in 2030, that is in between 2035 and 2064, and at 2017 between 271 up to the last century, that is 2100 on the upper Blue Nile part. And the Seri area is concentrated on the periphery of Lake Tana. This is the heart of the Blue Nile. So that there are 4 basic catchments that feeding to the Lake Tana, and the water comes out and goes to the downstream to join to the Nile River Basin in Khartoum. So the study area has around 15,000 square kilometers, and the major river feeding, that is Lake Tana, we have Gilgal Abai, Gumara, and Rib, and Magaj catchment. So we are going to see that the projection of climate variables over these 4 catchments and the runoff outcomes from these catchments. So normally this area has high rainfall, that is 1,465 millimeter, and we say that it is the heart of the Blue Nile. There's too much of runoff is produced from this catchment, which goes to the and contribute to the Nile. At the Blue Nile, I mean from Ethiopian part, we contribute annually on average like 52 billion cubic meter at the Ethiopian-Sudan border. So this is a potential area, so that we need to see and in detail and analyze the future impacts of climate change over the basin, because that helps us and determines the future demand of socio-economic development over the region. So normally this study area this is some of the gauging stations and weather station that is used to simulate the model. And as you can see that this is the elevation of the area where this is a lowland, and you can see in the tip parts of the catchment, this highland area where water is draining down into the lake. So we use the different data and methods. As you can see that the hydrological model of HMS is used because this is, I mean, that requires less input, and this model has been implemented and gives good outputs in different parts of the world, and there are different studies that used this model, so that we are interested to use this model. And we use 2 RCP scenarios, 4.5 and 8.5 scenarios for the 4 catchments. So some of the outputs of GCMM that we use the base period from 1971 up to 2005, and we use 2 climate variables, precipitation and PT, and so that the precipitation and the potential evapotranspiration resembles with the observed one, so that as you can see on the graph, the observed precipitation and the outputs of the 5 GCM is presented over here for 4 catchments. This is for Gilgal Abai, Gumara, and Rub and Magaj. As you can see that the observed resembles with the simulated precipitation of the projected output models from 4 catchments, so that these models more or less, I mean, that even though there are different uncertainties within it, but it resembles and gives the observed flow, the observed climate variables, so that we can able to use these base scenarios to forecast and see the projection in the future over the region. So the other one is the potential evapotranspiration, also gives a good correlation with the model outputs over 4 catchments. So based on that, we try to see the future projection of scenarios over the catchment, what looks like the precipitation condition over the catchment based on monthly and on annual basis. So this is the monthly and seasonal basis for 4 catchments for 2030 and 2070 under 2 RCP scenarios. As you can see that there is a, I mean, that precipitation change in all over all RCP scenarios over the catchment. This is the average RCP scenarios of all models outputs, and as you can see that especially during the summer season in Ethiopia, there is high rainfall, so that is the model also projected high rainfall, but the projection is high in the RCP 8.5 at the end of the century than compared to middle of the century. So the annual projected percent change fluctuates in between minus 20 and 30%. Almost all models produced or projected a positive change in rainfall, with the exception of Hadgam on Gumara and Rub, which resulted or exhibited a negative percentage change. And also you can see in 2017 in RCP 4.5, also the Hadgam GCM output exhibited a decrease in precipitation in Gumara and Arab catchments. And the same is true for RCP 8.5. I mean that the same case for RCP 2030. I mean that in the time 2030, RCP 8.5, produce a negative change in precipitation, but the other GCM outputs produce a positive change. So, and also the same in RCP 8.5, where all the modules produce shows, that a positive change in precipitation. So the other one is the temperature scenarios. The temperature scenario is expected to increase over the catchment. As you can see that there is an increment of temperature that ranges in between 3.9 up to 4.5, and sometimes from 7.1 up to 8.5 for RCP 8.5. So that means there is high amount of or variation in precipitation in temperature is expected, maximum temperature over the catchment. And this is the same is true for minimum temperature increase. That is, the temperature increases up to 4.5 degrees centigrade. So in all time horizon and scenarios, all the models produce a positive minimum temperature change in the future. That means the high change in maximum minimum temperature may result in high potential evapotranspiration over the area. So this may also have expected that too much of water will be evaporated from the area. So there, as you can see, that the potential evapotranspiration also increases in all scenarios and in both time horizons. So this may be contributed due to maximum and minimum temperature rise over the area. The other one is we use the HMS model calibration to test and use for runoff producing for each catchment. So the model calibration gives an acceptable result, and that has been checked by a Nascliffe coefficient, which is resulted more than 0.5. So that we use this model in order to validate the available data and see that the projection for future water resource availability over the catchment. So the model validation that we use from 2001 up to 2005, and as you can see that the observable simulators are more or less presented the same, except there is variation on extreme flow over the time horizon in 4 catchments. So based on that, so that the model can be used to simulate and produce a runoff for each catchment, so that we use that for both time horizon. And as you can see that in 2030, the increment of average runoff projection based on the 5 GCM gives up to 55.7% for RCP 4.5 and up to 74.8% of increment for RCP 8.5. And the same is true for 2070. There is a positive increment in both RCP scenarios, and more projection of runoff is projected or simulated from the model result in scenario 8.5. So in general, that the water resource availability over the catchment in the future will increase considering of other uncertainties. But from this model output, as you can see that there's more water is expected, especially during the summer season, that is rainy season of the area. So in general, what we can conclude is that in both time horizons, the precipitation, temperature, and evapotranspiration will increases, and that also results in annual runoff increases. And the water resource availability in general will increase, and that will meet the future water development demand if we use in a sustainable way and plan the strategy so that we can use the available water in considering of other factors, so that we can able to produce and meet the future water energy and food demand of the region. So there is a need that integrated action towards transparent cooperation for sustainable water development, and environmental sustainability is very important for mutual benefit of the natural resources. So that's all about my presentation. If you have any question, maybe later we can discuss. Thank you.
Thank you. Thank you very much, Santiago, for this nice presentation. There was like later we will discuss the questions with the panelists, but I just would like to say to our participant, there was a question about the presentations and the material of this session. I would like to confirm that we are going to share a PDF format for all presentations, and we are going also to share a recorded video with all our participants. I would like to thank up to now our two panelists, Emmanuel, and he tell us in his case study the impact related to land use, land cover change, and how these timber activities and human development impacted the water balance in that area. I would like also to thank Dr. Santiago for his nice presentation also, and how he used like different GCMs for different scenarios, RCP 8.5 and RCP 4.5 over the Blue Nile, and generating also some interesting results. Now we are going to move to our next presenter. But before we move to our next presenter, I would like kindly to remind our participant with some few housekeeping. Please type your name, affiliation, and country of residence in the chat room so that other participants can know who's present. And also for speakers, please mute your mic and turn off your camera, except when you are speaking. I would like to tell our speakers that you cannot type in Q&A because you are a panelist, but you can type on the chat area. I'm encouraging also our participants to use the chat room to share and exchange ideas. And also please post questions in Q&A feature. This will be responded to by our resource persons later. Thank you. So now we can move to our next presenter. Our next presenter is Wilberforce. He will present to us the intervention of rising lake level upstream of the Nile, a case study of Lake Victoria outflow. Thank you very much. Please introduce yourself first, Wilberforce, and then you can kindly present, and the floor is yours. Thank you. Wilberforce, are you there?
Yes, please.
Yes, thank you. Yes, kindly share your screen and introduce yourself first.
Okay, thank you very much, moderator. I'd slightly lost my connection, but it's good I'm back. Let me share my screen.
Very good.
I hope you can see my screen.
Yes, you can start. Before you start, introduce yourself kindly, and then start your presentation. Thank you, Wilberforce.
All right, thank you, Doctor. My name's Wilberforce Manirakiza from Uganda. I work with Uganda Electricity Generation Company Limited, and I'm a civil engineer in charge of dam safety and water resources, who was previously in Isimba hydropower project and now currently in Karuma hydropower project. Today I'll be sharing a presentation and also sharing experience on interventions we had to make for the rising lake levels upstream of the Nile, a case of Lake Victoria outflow. This will be the outline of my presentation. I'll introduce members, the Lake Victoria Basin, the White Nile Cascade, and I'll give an overview of that extreme event that we had since 2020. I'll also talk about the interventions we made, the effects of that event, the impacts and mitigation measures, lessons learned, recommendation, and then I'll conclude. Just to summarize, Lake Victoria covers a surface area of 68,000 square kilometers and is shared across 3 East African countries. It has 17 tributaries coming from a regional basin of 5 East African countries and has only one outlet, and that is River Nile. As I introduce you to the White Nile, before any construction took place, we might be aware that the Lake Victoria was being regulated naturally by just the geometry of a natural rock weir, commonly known as Ripon Falls. And then we constructed a dam just downstream of Ripon Falls and commissioned it in 1954, and that was the Owen Falls Dam, which is currently known as Narubale Dam. This impounding for this dam and the regeneration was being affected by that rock geometry, and that motivated the blasting of the lake, and the regulation of the lake was transferred to the dam from natural regulation to operators at the dam. Later, in 1964, we experienced the highest recorded water level in the lake while following the agreed curve, but in the end, it also motivated a study where the risk assessment advised that maybe we need to have another plant on the adjacent to the other one to increase increase the capacity of the outflow. That's what motivated the construction of Chira Dam just downstream of Narubale. Somewhere here, this is Narubale, this is Chira, and later, in 2012, we had just 16 kilometers downstream of Owen Falls. We commissioned Bujagali. In March 2019, we also commissioned Isimba hydropower plant, about 40 kilometers from Bujagali. And currently, we are still constructing 600 megawatt Karuma hydropower project just downstream of Lake Choga. It is also about to be completed. These are just the highlight of the features, silent features of these dams. 2 of the dams are completely only concrete dams, and the other 3 are composite dams. The design flood ranges between 4,200 to 4,700, and they all have a freeboard of about 1 to 2 meters. Just the overview of the event. As you can see, the first recorded highest level. If you see this graph in blue, this is for 1964. The highest level was 13.41 at the Ginger Pier, and it was in May 1964. This later decreased up to between 2002 and 2006. The lake regained or recovered its level in 2012 as it was rising gradually until May 2020, where the lake level surpassed the 1964 record, peaking at 13.4, also in May. And when superimposed, you can see a similar trend. Immediately, there are interventions as the lake levels were rising. The regulator of water resources, who is Directorate to Water Resource Management under the Ministry of Water and Environment, permitted a gradual increase in Nile discharges in a bid to mitigate the rising lake levels. It was done in incremental steps, as you can see these values here from 1,200 up to 2,400. This was definitely to minimize the shock to the ecosystem in the Nile and also to let the public adjust to the high discharges with time. It did not stop at permitting the discharges. The fact that there was a flooding, a national task force of different MDAs with senior experts who are technical in this field came together, and they were championing the flood mitigation. The plans also in the cascade did emergency preparedness awareness for communities around the dams. They also simulated some dam break drills, and to also make sure our dams are safe, we had to increase the frequency of dam surveillance in order to detect any defects early enough. I'll go through about 5 main effects of this extreme event and how we dealt with it, and what are some of the lessons that we picked. The first one, definitely on the lake, was flooding of the communities as the levels were rising. The communities around the lake were flooded, and the most affected were those who were illegally occupying the buffer zones of the lake. As you can see in the pictures, it led to displacement of people. The government was at some point forced to evacuate these people. But as we had seen, one of the interventions was to increase the permitted discharges through the Nile, so as to reduce the levels. As you can see, it also affected economic activities and some businesses around the lake. Now, the increased discharges through the plants came with the instability of floating islands, which became a big issue. As you can see, this is Nile Valley in the picture, and a big floating island approached the plant, clogged the trash racks, and in the end even led to a national blackout. This also led to head losses and reduced energy output, and the fact that the trash racks were being cleaned more frequently, there were high maintenance costs. But a combined and coordinated multi-sector effort was used, where MDAs like Ministry of Agriculture, like other key stakeholders like Uganda Police, Uganda People's Defense Forces, Uganda National Roads Authority came together to disintegrate the floating islands and remove this debris and deposit it in a permanent disposal site. As you can see, after 10 days, the first floating island had been removed with a concentrated effort. But later, other floating islands also emerged, but good enough with the mitigation measures that had been put in place. There was much more reservoir surveillance so that they can be trapped in the upstream of the dams so that they don't affect generation and the safety of the dams. And they were removed from as far as away from the dams. As you can see there, that's a tugboat with equipment trying to remove the floating islands. As we continue, as we continue towards the Nile, on the immediate terrace, on the immediate downstream of the dams, these increased discharges also had much effect on the banks, and there was excessive erosion, and there was exposure of the foundation of the dam too, and this was creating reduced stability of the dams. There were interim measures that were put in place, including slope protection, use of sandbags, and at the moment at Naruware, we are having grouting works in order to increase stability and between the dam and the foundation. On the downstream, this is Chira, and it was also having an effect on the sides, on the banks, and this is the switch yard which was being eroded. But also in this case, we had to put interim slope protection measures. As we continue downstream, you can see this is Bujagali, also having some slope collapses here and here. We have also Isimba on the terrace, excessive erosion. So almost each plant had the share of this cake of erosion. As apart from just the immediate surrounding of the dams, we had reservoir collapses, and even along the river banks, there were collapses, as you can see in the pictures. This was creating uptake of land, uncompensated land, and bringing social issues, but they are countered by engagements with the community. And the overall mitigation measure we are looking at is to inspect and survey the slopes, carry out geotechnical investigation, do stability calculations, and do appropriate slope protection measures that will last. The immediate intervention was also cascade coordination, as we shall see later. On the effect on hydropower production, the first increase in flows from 1,000 to 1,500, for example, at Isimba, were on a good side, as we were able to have more water to generate more power, and we were able to have maximum output up to 183 megawatts. But when it went beyond 1,500, the discharges would quickly raise the terrace level and would consequently reduce the net head. In the end, you would have head losses and would have reduced energy output. As you can see, this is the net head corresponding to the increase in discharge. The net head reduced, and also the generation was, maximum generation was also reducing. But in this case, we adopted optimum reservoir operation procedures, also created a cascade data sharing platform, and we did cascade discharge tests in order to be able to forecast the flows and plan accordingly and in time. We also had, we are still having prolonged operation of the spillways, and we are having too much scoring of the stealing basin just downstream, and abrasion and erosion of the terrace. We also got public safety concerns where we had one unfortunate event where a boat that was around the source of the Nile lost control and was swept through the spillway. And unfortunately, we lost 2 out of the 4. The other 2 were rescued. So there were also public safety concerns. And this helped us think about a mitigation measure of developing and implementing public safety plans in future, including maybe setting up safety booms to control or create any barrier from the spillways. We also had disruptions of economic activities. For example, in Isimba, there is a ferry that was being operated, and those discharges and some high levels would disrupt its operation. There was a bridge connecting Kayunga to Kamuli, which was under construction, that required a certain maximum terrace level. And there was also definitely fishing and tourism activities that were affected. These were dealt with through coordination, cascade coordination, coordination with ferry operators and bridge construction, while doing a give or take depending on the situation. We mostly used a siren in case there was we were going to have a large discharge that would threaten any downstream activities. That's how we would mostly communicate. These are generic lessons learned from those events, and some of them are previous lessons that are already documented, but they also applied to our experience. One of them is the necessity to address public safety, and definitely public safety education is very important. Floating booms, we need to have a robust floating boom for on the upstream of the dam of Nalubale, since it is a place that is prone to floating debris. We need to also consider a reserve source of funding, like an emergency funding, to deal with certain emergencies. We learned a lesson how important potential failure mode analysis and risk analysis is very important. Good enough, we had done this risk analysis, and we had risk registers which we had to look at and also update with the new risks that were involved. And they really helped a lot in dealing with these extreme events. We also learned how emergency warning can be an effective way of warning the downstream water users, as it was the way we are communicating with fishing communities, with the ferry operations and the construction. Also picked lessons like how regular monitoring and inspection can help in early detection of dam safety related incidences, most especially in these extreme, while dealing with these extreme events. We also picked the fact that appropriate reservoir operation and inspection does not only help in optimization, that we shouldn't focus only on optimization of power production, but also look at mitigating any dam failure risks. It was also important to note that failure of upstream dams needs to be considered in any design and dam break analysis of any cascade of dams. That is to mean closely spaced dams. On the lighter side, we had managed to do this while preparing the emergency preparedness plans for Isimba and Karuma. On the specific side, we picked some specific lessons where we are confident now that the government of Uganda has the capacity to mobilize resources and respond quickly to emergencies, like the way we respond to those floating islands. We also picked the lesson of how such power system stability is of great concern to the country, and we need to see how to deal with a way of reducing national blackouts. We also saw that these hydraulic power plants are exposed to serious dam safety threats and revenue generation losses if we don't put a robust rock boom to contain any floating debris or any emerging floating islands on the upstream of Owen Falls. We need to adapt also the dam operations to the inter-annual variation of precipitation and lake levels, and also consider effects of climate change. There is need to do future hydrological studies in order to minimize any inherent model uncertainties. Also, to emphasize, we only used to look at Nalubari and Chira mainly to look at that they are there for hydropower generation, but we are able to understand that it is a strategic asset for the country that also is responsible for flood control, controlling a flooding of Lake Victoria, since it's the only outlet. We also realize that we need to regulate the Lake Victoria outflow in order to mitigate any seasonal changes. Stability analysis, we did stability analysis for the dams, and we realized it is important to do it, most especially during these extreme events. It gave us comfort that the dams were stable and strong enough to hold this extreme hydraulic load. There's also urgent need to build on the Uganda Committee on Large Dams initiatives, and then strengthen the nation's dam safety and regulatory framework. Currently, we don't have any dam safety regulatory framework, and we really need to develop one so that the dam operators and the other responsible authorities can take responsibility in case of any failures. On the side of recommendations, I believe that we need to undertake studies on the impacts of climate change, detailed studies on impacts of climate change on Lake Victoria Basin, and how it can impact the hydropower generation, and then it will inform the adaptation measures that dam operators can take. We also need to develop and build and implement a real-time flood forecasting system and early warning system. I believe if this flood was forecasted early enough and the gates or the release at the Owen Falls was done early enough, then we would have drawn down the lake and it would have accommodated the increased flows that were coming from the tributaries, and we would have prevented this flooding. So a flood forecasting and early warning system is really very important for this Victoria Nile system. As we all know that human capital is very important for any initiative, I think Nile Basin Initiative should consider initiating and supporting a young Nile professionals forum so that they can mentor them and build their capacity so as to champion the Nile cooperation for today and tomorrow. In conclusion, I must admit that this extreme event tested our current principles of flood and dam safety management, but we also saw some opportunities. For example, in Isimba, where we are still in defects liability period, we are able to discover some of the inefficiencies in construction, where now the contractor had to do the immediate repairs before the end of the period. We also learned that our risk-informed strategy was very important in dealing with this extreme event, and our risk register was very instrumental, and we have to maintain it. At the pinnacle of all this, I believe we need to create the dam safety regulation for Uganda with that objective of protecting downstream population or downstream life or property and environment from any harmful effects that can come out of misoperation of these dams or failure of these dams. All in all, we were able to improve our cascade cooperation and I think it shall go a long way to avert any future risks and impacts of changing climatic conditions. We remain UGCL, generating for generations, and with support from Uganda Committee on Large Dams. Thanks for listening.
Thank you, Wilberforce, for this nice and excellent presentation. You focused on a very important topic, which is this unprecedented rise of Lake Victoria, and also the impact of this floating island and the erosion in different dams. You looked also at the effect, the impact, and the intervention. Also, your recommendation for the MBI, it is noted and written. Thank you very much. And before we go to the next speaker, I would like to remind our participant with some few housekeeping, please. Please type your name, affiliation, and country of residence in the chat room so that other participants can know who's present. And also for speakers, mute your mic and turn off your camera, except when speaking. And also please use the chat room to share and exchange ideas. And for our panelists, they cannot use, of course, Q&A. You can use the chat also. I'm encouraging also our participants to post questions in the Q&A feature. This will be responded to by the resource person. I would like also to remind our participants that we are going to share all our presentations and even these videos of the session in our link in the Nile Basin Development Forum. Thank you. So now we can go to our next presenter. Our next presenter is Dr. Bob Alex. His presentation is about climate variability and change. So Dr. Bob, please first introduce yourself, and then the floor is yours, Dr. Bob. Thank you.
Thank you very much, Dr. Mudathir, for giving me the opportunity to make a presentation. I'm sorry, I've just joined you people. I had another very lengthy meeting, which has just ended.
You are welcome, Dr. Bob.
Mudathir, kindly, can I have it uploaded from your side?
Okay, so you want us to share your presentation. Patrick, can you please share the presentation of Dr. Bob from your side, please?
I can do it even from here.
Okay, I can also, if Patrick can do it, then it is fine. Yes, thank you, Patrick. Thank you very much.
Yes, basically, I'll be at, I'm sorry,
Before you start your presentation about the annual state of climate of Uganda, can you kindly introduce yourself, and then you can start the presentation about the annual state of climate of Uganda 2019. Thank you.
Thank you very much, Mudathir, for the opportunity, as I said. I am Bob Alex Ogwang, currently working as the Director of Training and Research in Uganda National Meteorological Authority. I've been in this office for nearly 3 weeks. I'll basically be talking about the annual state of climate of Uganda, particularly for 2019. Can we move to the next? Next, Mudathir. Basically,
yes,
I'll give a brief background and then look at the data sets used in the analysis and some results, and I close it. I've been told it's just about 10 minutes presentation, so I left almost everything out. But usually the annual state of climate helps to reveal the extent of climate variability and climate change in a given location. Now, at the global level, this is usually done by the World Meteorological Organization. They started making the publication for the annual state of the global climate way back in 1993, thereabout. Then at continental level, the African Center of Meteorological Application for Development, which is a World Meteorological Organization designated regional climate center for Africa, is responsible for developing the annual state of climate over the African continent. Then at national level, the different countries are supposed to develop the annual state of climate in line with the guidance from the WMO. For Uganda, we started in 2017. Next. Basically, in the analysis, we've looked at temperature from 1950 up to 2019, and rainfall from 1981 to 2019, based on the base period for the World Meteorological Organization, which is for operations. If you want to get, say, the climatology of a given area, operationally, we use 1981 to 2010 as the base period currently. Next. This is the assessment, the national assessment of temperature. I'm wondering whether members are seeing it very well. To me, it's a bit small. Now, from this analysis, we got the annual temperature for each year from 1950 to 2019, and then got anomaly. Anomaly is basically the difference between what is observed and what is expected, the climatology, based on 1981 to 2010. So if you get the difference between what is observed each year and the base period, which we are calling climatology, gets the anomaly for each year. So in this figure, we ranked the temperature anomalies. And as you can see over here, 2019 broke the record. It was the warmest on record since 1950. And then if you look at the warmest years, the 20 warmest years so far since 1950, they all come after year 2000. And what does it tell us? It's an indication that there's something going on. There's a rising temperature over Uganda. And as we rethink investment over the Nile Basin, we need to consider at all levels climate issues, including research and investment. Next. On this one, we plotted temperature anomalies basically to show the rates of temperature rise over different time periods. The black line running across from blue down here upwards, that trend line is giving us a rate of rise of 0.2 degrees Celsius every 10 years. And then if you look at the recent years, this one, which is green, from 1990 to 2019, the rate of rise of temperatures is even higher. Considering the temperature rise from 1950 to 2019 over there, the rate of rise is 0.23 degrees Celsius per decade. But in recent years, from 1990 to 2019, the rate is higher. There's a message there, again, that the warming is higher in recent years. Something must be going on. And this called for a lot of research in this area. Our role basically was to show what is happening, what is the rate of rise over the two different periods. So the temperature is rising. As we think about investment in the Nile, over the Nile Basin, let's consider what is happening in the individual countries. Are the temperatures rising uniformly or differently, and what is causing it, and how do we respond as we invest in the region? Next. This is basically the mean annual temperature, annual precipitation, but basically rainfall, but I choose to use the general term precipitation in percent of average. That's the percentage precipitation for 2019. We've compared with the climatology, which is the average from 1981 to 2010. And if you get the percentage, you'll see that most of the regions here between 75 and 125%, we consider it to be normal. So the whiter areas are normal. Towards the red color is below normal. And you can see that 2019, we had generally between normal to more than normal, above normal. But normal in the sense that if you get a percentage between 75% and 125% of the climatology, of the expected value, we call it an area of normal range. Anything above it, above normal. Anything below 75 is below normal. So you can see 2019 was full of normal to above normal rainfall received in the region. Here we didn't look at the reasons for this, but the other studies available can explain some of these occurrences. Next. This chart gives just a summary of what transpired in 2019. We were comparing what transpired in 2018. And as you can see from the left top corner, 2018 was the 7th warmest on record since 1950. And we looked at the national warming levels. The temperature anomaly for 2018 was 0.37 degrees above what is expected. Then in 2019 was much higher. That was 0.78 degrees Celsius above what is expected. And here we are calling it the warming levels for 2018 and 2019. Generally, 2019 was the warmest, as I mentioned before, warmest on record since 1950. And this was mentioned earlier, the blue one, the rate of warming, if you consider the entire period, which we consider for analysis, 1950 to 2019, the rate of warming 0.23 degrees Celsius for every decade. And then in recent years, you can see that it's much higher. In Uganda, from the analysis is not shown here, Western Uganda is warming faster than the rest of the regions. And I just captured this out of a bigger analysis. We had a lot of issues of flooding, mudslides, loss of lives due to above normal rainfall, which we receive in the region. Next. Next, please. And we go to the next slide. Basically, as we rethink investment in the Nile Basin, it's our role to consider from this observation where we are saying the temperatures are rising in different countries and the rates of rise are varying. In Uganda, Western Uganda is warming faster than the rest of the countries. rest of the regions. We need to, the first part, to consider all aspects of climate as based on the warming rates shown. As we are investing, let's make sure that our investment covers issues of climate. Is it climate research? Is it investment in capacity building, investment in equipment, and many others? This will help us to align our investment. And secondly, we need to invest wisely in climate science, as I mentioned, because it will enable us to make the right decision if you want to construct, say, a dam or something else. Is the climate interest captured? So the decision making will be key if we invest in climate science. And I can say that under my docket, where we have training and research of Uganda National Meteorological Authority, we are open to collaboration, basically, research and training, building capacity, and working together with the NBI and the forum at large. Next. Please, can we move to the next one? Oh, thank you very much. I'm sorry, I left most of the things out because of the limitation of time. Back to you, Mudathir. Thank you for listening. Thank you for your attention.
Thank you very much, Dr. Bob, for this nice presentation about the annual state of climate in Uganda, and also your experience in this national assessment of temperature and rainfall, and how this continuous historical increase of temperature is happening, and the trend in temperature and rainfall. Thank you very much. Please stay with us, Dr. Bob. We are going to have some few questions after the final presentation now. Now we are moving to the last presentation in this session. The last presentation is by Engineer Ridwan Abdurrahman. He is presenting to us manage climate extreme events, risk and uncertainty. The floor is yours, Ridwan, Engineer Ridwan. Yes. Can you introduce yourself, and first, please introduce yourself.
Thank you, Dr. Mudathir.
Kindly share your screen. Thank you.
Thank you, Dr. Mudathir. Good afternoon for everyone. I am Ridwan Abdurrahman from Sudan. I am working in Ministry of Water Resource. I am head of flood forecast. So, okay. So, outline of my presentation, the periodic of the occurrence of river floods and flash floods, and variability of rainfall or rising in temperature, and key solution. So first, what happened in the last years? There is increasing in frequency of flash flood and riverine flood. Flash flood is really, it has very large impact on the agriculture area, or even in citizen or on city, and riverine is a little bit can be controlled, but flash flood is very affected on the people. So everyone knows that the last year, 2020, Khartoum and Sinnar are bad hit by post-referine flood and flash flood. Before it, only if you count the frequency, we find it's yearly. It's not given even 2 years. 2019 also there is flash flood. 2018 there is flash flood. So the repetition is or the return period is almost we come to the every year. Yeah, no, we have no even no longer to wait. So the more affected area in Sudan, you see as in the map of the Sudan, the Blue Nile, also there is Kassala, and in western of Sudan, there is some wadis and khors. Also, there is flash floods there. This is for photos of some of it is flash flood and some of referine flood. This, what is confirmed these pictures? It is confirmed that the climate change already take its place, and what we do now. If we go to the Sudan zone, climate zone, this we have in Sudan about 4 climate zone. Hyper arid, this is completely desert, and arid and semi-arid and sub-humid. The area of arid, in between arid and semi-arid, this is one of the important belt for agriculture and also Arabic gum. Also for pastoral, that belt is very important. So from the climate change, we can see how this belt can affect it. Now this is superimposed of rainfall on the zones. If you see that there is clear shift to the south, so this another way we prove that the climate change already take place, and now really climate change not we talk in future, but it is becoming real. Now this is also another event, annual rainfall over Al-Fashir. This at this city at the zone of an arid zone. So it is clearly there is decline in quantity of annual rainfall. If you see this inclination is 1.4 millimeter per year. This inclination in average is 1.4. The inclination of this trend is 1.4. So 1.4 actually per year. So this also evidence of that climate change take place in Sudan. This another evidence also rainfall trend in another place in Sudan. This is near to the Khartoum in the same belt. Also the trend is going to fall down, and Kassala on the east in the same place. So we are not left place in the belt of the arid, in between arid zone and semi-arid zone. This is the important belt, as I mentioned it before. So now all the rainfall or average rainfall is going to decline, and this is proof exactly what I said. There is climate change take place in Sudan. Another proof, there is temperature rising, and this is at Adbara and Gadarif. The trend is going to rise. So this is also the effect. So climate change impact the sector of agriculture, forestry, and water resource as follows. Agriculture sector, drought is threatening the existing cultivation, rain feed, and mechanized rain feed at Gadarif. Also, rain feed at Kordofan and Darfur. This is the belt I mentioned before. And pastoral also they are affected from this. And by the way, this can lead conflict between pastoral and farmers, because anyone now there is competition in the water resource, so it leads to the conflict. This is a decrease in crop, and also decrease in crop production, decline on rain feed, because there is fluctuation in humidity, and rainfall is not enough. So even into space, in spatial and temporal in time, the intensity of rain is not enough for the vegetation or for crops, so it reduces its productivity. Another something important for Sudan is Arabic gum. This is also lay in the belt of the agriculture belt, and this kind of terrain need somewhat is humidity, and when humidity is reduced, then the productivity decrease. This is I already mentioned, humid agro climate zone shifted south wards, rendering area of the north increasing unsuitable for agriculture and lead to increased sandstorm. This also lead to another things, sandstorm on the north. Now sandstorm creeping towards the course of the Nile. And this want to bury the course of the Nile. This increase the evaporation, also the infiltration. So now we see that the climate change already took place in the Sudan. Climate change does not know borders. If we see that from my colleague doctor who present the paper about Uganda, we see also the trend is there. So the same trend. So the climate change is regional. It's not for one country. See, this is not know the political borders. So what we can do, all we can do, establishing a regional hydrometeorological and meteorological monitoring network in flood and drought vulnerable areas in order to enhance efficient early warning system at community, institutional, and regional levels, especially in flood and drought prone areas. So what I saw from your presentation earlier, I find part of it. So if we have good hydrometeorological or meteorological monitoring network, so we can enhance the model and we can predict what it become, and people can adapt themselves to the climate change. And regionally, this is regionally and maybe also at local people. Encouraging water harvesting, targeted agriculture, and management practice. So also we encourage water harvesting, target agriculture, both for pastoral, for livestock, and for vegetable. So we can increase or we can enhance how to harvesting water. In Sudan, one type of harvesting water called hafir, but other people can do terraces or according to the place or according to the country. We are all supposed to managing together. So what is the solution for this? We invest of information, information. If you have as regional, not one country, we have information infrastructure at both institutional and regional level, and we cooperate and manage of shared water resource can optimize regional win-win benefit. We can cooperate and supposed to we have information infrastructure. We are together, and everyone can share this water resource. We can optimize regional win-win benefit and mitigate flood and drought disaster and minimize tension between riparian state, as you know that sometimes will be tension between riparian state, but if we are going to manage and share water course by infrastructure, we can solve this problem easier, and we can all help the other, and we can adapt ourselves as country to this climate change. Now the climate change is something being reality. So what we do is how to cooperate, and we live with it. It can also help maintain shared ecosystem and improve water and agriculture productivity. Thank you.
Thank you very much, Engineer Rudwan. Thank you very much, especially for the last statement. I like it very much that climate change doesn't know borders. This is a very nice statement. And thank you for presenting about the past floods in Sudan, and also you talked about the climate zones and the rainfall and this shifting in the climatic zone. And also you talked about the creeping of this sandstone towards the Nile. Thank you for this nice presentation. I think now we can move to the last thing. There are some few questions to the panelists. Please, when you receive your question, open your camera and microphone. So the first question for Emmanuel. There is one question. Can you do a similar analysis with projected stream flows? There is one question here, Emmanuel.
Yes. Are you hearing me, moderator?
Yes.
Yes, thank you so much. I didn't get the name for the gentleman who was person who asked this question, but it's possible. It's possible to do it, and I think in the next workshop, or maybe before April, the end of April, I would present the results for the projected stream flow and land use. There I had another one which was from Rutaya, from Sunrise, Uganda. It's one of the newspaper here. He was asking of the enforcement on the wetland and the encroachment. Personally, I believe improved coordination, the coordination in enforcing the laws that are existing in the country would do much in averting or reducing the high rates of the rates of wetland degradation and other natural resources. On a personal level, I would think that now it's high time that we move on for an environment court, such that we have really action taken, so that we can as well address any other issues quickly that would come, but also the cases that we have in our courts as regards to environmental degradation. I think that would quickly address the challenge of encroachment on our wetlands. Yes, I think those were the ones that I noted.
Thank you.
Thank you.
Thank you very much. Thank you, Emmanuel. The second question, it is for Santiago. Can you please open your microphone and camera, please?
Okay.
Yes. There is one question here. Why you selected GCMs and not RCMs? Why you selected these like 7 global circulation models and you didn't use maybe regional climate models? This is the question. Thank you.
Yeah, I think I didn't mention about the RCM. Actually, we first we use the GCM, then we downscale it into RCM. So that I should mention actually the process, but due to time, I just want to only focus on the result part. So we already used the RCM for the region. So, and we process the data. That's why we try to get refined and very precise data in order to simulate and project the climate variable and also the water resource availability. So we already use the RCM for the region study.
Thank you. Thank you very much.
You're welcome.
The second question is for Wilberforce. There is one question. Can you please open your mic and microphone, Wilberforce? Thank you. There is one or two questions. The question is, what explains the high water level up to now? Because the heavy rainfall, it was in the last year. So there was like one question here about what explains like these high water levels up to now in Lake Victoria, and who takes the decision regarding the releases? Thank you.
Okay, thank you very much. I'll first start with who takes the decision. It's the Directorate of Water Resources Management, who is the custodian of water resources in Uganda. And this directorate is under the Ministry of Water and the Environment. About the high levels even up to now, first of all, like I said, we have 17 tributaries bringing in water, and you have only one outlet. So you'll find with the last 2 years where we have had heavy rainfall beyond, according to Uganda National Meteorological Authority, you have had for the last 2 years above average rainfall in the whole region. So you expect all that in the whole catchment, in the whole Lake Victoria Basin coming to Lake Victoria. So the storage that we have, the excess storage right now, cannot be so much relieved by the current flows. And even the flows that we release, we must make sure that they are not so much threatening and damaging the downstream. We have to balance between the upstream and the downstream. So like I shared, we first increased from 2020 in steps up from 800 up to 2,400. That was 3 times, 2,400 was 3 times the normal flow that the River Nile, the White Nile, normally gets. So when the levels went down in the beginning of June, then we went back from 2,400 to 2,000. But at the moment, the rains are starting and the levels are starting to go back high. So we had to again increase the discharges. So the discharge is at the moment at 2,200. And the other thing we should have in mind is that studies have shown that we have cyclic wet and dry phases for Lake Victoria, and they occur for a duration of 5 to 10 years. If we could go back to history where we had that event in the 1960s, the lake levels were rising since 1960 and went to the maximum in 1964. So there is a possibility and a high possibility that the lake levels that started rising in 2000 will actually continue rising for even up to 5 years. So we still have this big task ahead of us of controlling the lake levels while also making sure that the downstream activities are not threatened that much and are not, we don't do much damage on the downstream. Remember that on further downstream, there is Lake Choga, there is Lake Albert, and as you release, there's also flooding in those areas. So we have to balance the whole system.
Thank you.
I hope I've answered that question.
Yes, thank you very much. The last question, it is for Engineer Ridwan. We know that the floods in Sudan, they did not generate inside Sudan. It is because of high or heavy rainfall at the sources of the Nile. So the question is, do you monitor the rainfall from global, maybe observational data set or some free available data set at the sources of the Nile? Because these, many times, these are the cause of the floods in Sudan. So do you monitor the rainfall at the sources of the Nile, Engineer Ridwan? Thank you. Please open your mic and camera.
Yes, thank you.
Yes.
Maybe my device not commit this, but regarding to global, really we from your last presentation also we saw something is a little bit different from previous years. But what we're looking for now, the flash flood is the frequency of flash flood, not on the eastern part, but in the western part. So the two different system of the rain, the source of the rain is coming by different. So this will be globally really, but we need a RAPSAT or a strong model to give this or to give confidence about this is globally, not locally. Okay.
Thank you. Thank you, Engineer Ridwan. The final question, I think it was for me. How can decision makers benefit from this information that we generated here at NBI? So the answer is we shared all our products with our stakeholders. We have a list of around 2,400 stakeholders, and we share normally our products, our models, and even the data set that we generate here and even like this kind of event now. So we share this information with our stakeholders, and before we share them, we approve them by the countries. So all this information are shared with the countries. And for anyone who would like to be one of our stakeholders, he is welcome. He can contact us, and we will add him to our list, and he will receive always many products. There was like one question here for Dr. Bob, but Dr. Bob apologized. He has an urgent meeting now, so he will not answer that question now. There is also one final question about why you selected the RCP 4.5 and RCP 8.5. RCP 8.5, this is like the worst scenario, and RCP 4.5, this is like the medium scenario, and they were always used in many papers because they give like a good representation about the projection. Thank you very much. The last thing we would like Ammar Jabir to give us like the final messages and remarks of this session. Please,
Dr. Modatir.
Yes, please.
Did you read the? I'm sorry, maybe my connection is
Yes, please. Madam Jacqueline, the TAC of Rwanda, and currently the Nile TAC chair. You are welcome to pose any question or to give any feedback or reflection, please.
I would just request you if you have read the question on chat, because I see there is a question from Anna Cascao. There is a question for many people. I don't know if you have responded all those questions. Thank you.
Thank you very much. Yes, we responded to some questions of Anna Cascao. She asked about the rising of Lake Victoria, why it is up to that level up to now. And our panelist here, he responded to that question. She also asked one question about who take the decision for releasing the water. It was also answered. So yes, we tried to pick like many key questions, but maybe we may like miss to answer one of them because of the time now. We're supposed to end at 4. So we are trying to just summarize and at least ask each of the panelists one question. But thank you for your concern.
Thank you. Maybe I was offline. Thank you so much.
Thank you very much, Madam Jacqueline, the Nile TAC chair. Now, I would like, please, Ammar Jabir, can you kindly, please, now maybe give us like the final messages of this session and the final remark and summary, please, maybe within 2 or 3 minutes. The floor is yours, Ammar Jabir.
Thank you very much, Dr. Mudathir, and all.
Please introduce yourself, Ammar Jabir.
Did a very excellent job, and also.
Can you please introduce yourself first, and then you can give us.
Okay, sorry. My name is Ammar Jabir. I'm from Sudan. I am the Secretary General of
Ammar, the Secretary General of International Forum of Meteorological Societies.
Yes.
Sorry, we couldn't hear you.
International Forum of Meteorological Societies. Yes. This is. Okay. Are you hearing me now?
Yes, yes, very clear. Thank you.
Hello?
Yes, we can hear you. Go ahead.
Hello?
Yes, we can hear you.
Okay,
Go ahead.
my name is Ammar. My name is Ammar Jabir. My name is Ammar Jabir. I'm from Sudan. I'm the Secretary General of International Forum of Meteorological Societies. And I have the pleasure to report toward this webinar. And I would like to thank the organizers and also the panelists. As I said before, they did an excellent job. They provide very rich information concerning the impact of climate change on the hydrology of Nile Basin. They showed a very useful and concrete experience and studies over the countries, Uganda, Ethiopia, and Sudan. And also we heard from the opening remark that the climate change is impacting the Nile Basin, and this is now very, very obvious for all of us, and this is a call of work for the decision maker to do their best to mitigate this impact, and also to set a response plan to eliminate or at least to minimize the impact of the climate change on the water resource, and also for the human being in the region. For sake of the time, I just would like to mention the key takeaways from this webinar. The first one is the investment in information infrastructure, and mainly the panelists talk about the importance of monitoring over the catchment areas, and also data availability, data sharing. And I would like to thank the NBI. They did excellent job for providing the necessary information for decision makers through their decision support system. And so they can do more effort in providing more data by installing like monitoring rain gauges or station or in the basin, and also utilizing of satellite information. And I think this is an alternative means of data resources, and it will do an excellent job in monitoring and also in modeling. Also utilizing of the modeling and reanalysis data to produce a reliable forecast is very crucial. And I think the NBI started doing this modeling and also climate change scenarios for Nile Basin, and we need to see this available and utilized by the members. Also establishment of early warning system. Many panelists talk about the early warning system, and it is importantness. And also this is important because it will provide lag time for the practitioners and decision makers to do the necessary actions. Establishment of risk assessment. And also I heard the moderator talk about the climate change assessment, and actually this is a very good initiative, and we need it. We need to do climate change assessment to allow the decision maker develop the necessary strategies and planning. So establishment of risk management, risk assessment is crucial. Also establishment and strengthening of the collaboration between NBI and National Meteorological Services is highly needed. And this is highlighted by Dr. Bob, I think the Director General of Uganda National Meteorological Authority. Yes. So, and he also offered collaboration, and he said he is ready to collaborate with NBI in training and also in joint research. And I think this is valid for the other national meteorological services in the Nile Basin member Sudan and also Ethiopia and other members. And also, as highlighted by some of the panelists, the joint research is crucial. Utilizing of the climate change scenarios and downscaling it and provided it to the decision makers is also highly needed. Just this is to take the time, but we will provide a very comprehensive report about this is topics. Thank you very much.
Thank you very much for this insight, and thank you very much for capturing these takeaway messages. You did a very good job, Ammar. Thank you very much. I would like also to thank all our panelists here, and I would like to thank first Madam Jacqueline, the TAC of Rwanda, and the Nile TAC chair. I would like to thank also Ammar, Jabir, Anna Kaskau from the GIZ, our panelist Emmanuel, Dr. Maha. I would like to thank also Leonard Akwani, Dr. Azza, for a lot of work behind the scene. I would like to thank also Engineer Rudwan. I would like to thank Santiago, and also I would like to thank Wilberforce and Dr. Bob. Thank you all. And I would like just to close this session with this nice statement, which said, climate change doesn't know borders. So this statement by one of our panelists, it was very inspiring, because we need to continue work together as MBI countries. And also, as Ammar said, we need to inform also policies through science. This is also very important. Thank you all very much for joining the first session of the climate change for adaptation. And I hope you will continue also attending the other interesting session for this climate change. Thank you all very much, and bye-bye. Thank you.
Okay, thank you.